Are there any questions before we get started? What we have been discussing? Okay. So I want to talk about one more thing before we start running the model, actually. One other thing I want to mention is the decision tables. So currently, you can have decision table. This is one of the major difference between SWAT and SWAT plus. You can have decision table for land management, reservoir release. So if you have a reservoir and you want to know how the reservoir is operated, so you can have multiple reservoir release rules. So you could say when the water level goes below a certain level, don't release water at all, or reduce your hydropower production by 50% that goes through turbine. Or you could say what is the minimum water you have to keep in the river for base flow downstream, in how much water you have to release, things like that. So you can have various reservoir release operation rules that you can use actually. And then you can also have the land use scenario. We talked about, I think one of the questions from online was, how do I change my land use? Do I need to give multiple land use layers versus how to run scenarios? So that's what the land use scenario here, example here. Then you can also sometimes manage based on flow conditions. What is a flow condition? You could say irrigate only when the water is above certain level or certain volume in the river. Otherwise, you are not allowed to take water from the river, for example. Okay? So you can put lots of conditional management in your operation. So this is a dynamic. The decision tables are implemented every day of the simulation. So if it meets the condition, it triggers certain action. Okay? And it implements certain rules. If it doesn't meet the condition, it does not implement that actually. Let's say irrigation rule. Okay? If it doesn't meet the irrigation rule, then it will not implement irrigation. Okay? So even it triggers, sometimes it will not implement if the source of the water did not have enough water to irrigate. Okay? Just because it meets the condition, it will try to implement, but it may not be able to implementable because of lack of water. Okay? So there are lots of things going on here actually. So what happens in 1 year may not happen in another year because of the rainfall pattern changed or irrigation requirement changed and whatnot. So all those things you need to keep in mind. One other thing that we are struggling in the model is to document every time the rules are triggered and successful. Okay? The rules could be triggered but not successful also actually. So as a user, when you look at the output, you need to know why did it happen actually in the model? Because the inputs are now based on decision table, not based on actual input, like irrigate on day X. We are not irrigating anymore on day X because our irrigation is based on rules now. So that day X may change few days in 1 year, few days in another year. So it is not going to be any more fixed time frame. Okay? This is what happened in real practical example, actually our practical farmers field. They are going to take all those weather information, land information, climate information, and crop information, and then decide, should I apply pesticide or not apply pesticide? Okay? Should I apply fertilizer now or later? Should I apply irrigation or not irrigate actually? So all those decisions are made not purely on dates, it's based on the current condition. Okay? Various conditions. So we are trying to mimic how the farmers will make decisions and then put them as a rule so that you may have all this thing in your place, the managements are in place, but that management may not get triggered until the rule is satisfied, until the decision rules are satisfied. So that's a key message here actually, why the decision tools are there, why it's there. So let me show you some example of how you can create actually. So we have a few examples here. For example, in the land use management, so these are all some of the existing rules. We already have given enough example rules, for example. Okay? So let's look at fertilizer, forest cut. Okay? We are going to, this is a managed forest. You are going to cut the forest once in 20 years, 30 years, however many years. So you can see this, how many conditions are there? There are 2 conditions, 1 action. Okay? So if you want to look at how it looks, okay, you can see the information here. I know this sometimes is descriptive or not descriptive. It's kind of not very intuitive by looking at that. So we also given you a descriptive thing that puts you in a natural language. So the interface is not fully developed for this. What we are hoping is you will write in a natural language and we will convert that into the input in this format. Okay? So that's the idea here. So for example, okay, if the current maturity of your forest is at least 20 years and you're going to harvest, let's say, in the fall or in the later time of the year, at least the Julian day is 295 days or more, then cut my forest. That is a simple rule of minimum maturity date is 20 years or more. Okay? So it's basically 2 conditions, right? 1 action. Action is cut the forest. Okay? So that's what here. There are 2 conditions here. Okay? 1 row for each condition. So the first condition is saying the limit should be, that means at least it should be 20 years. And the Julian day should be at least 295 days. Equal means it should be at least equal to 200 or more. Okay? Then what is the action? 1 action, which is harvest the tree. Okay? So this is a management operation in your decision table actually. If you go back to your database, and here one of the operation will be the harvest that will say how to harvest a tree. So you can have a harvest for grass, harvest for grain, harvest for biomass. So you can have different types of harvest operation. So here it is tree harvest. Does that make sense? Okay, that's just one example. Okay, let me go back and pull up another one, for example. Grazing. Somebody was asking about grazing, right? Animal operations and things like that. Okay. So again, there are 3 conditions and 1 action. Okay. So you can see this. If the Julian day means from January 1 is the day 1 up to 290 sometime in October. Okay. So if the Julian day is greater than 295 and you still have a biomass of more than 3,000 kilograms, then you can have animal grazing the land actually. You can still allow the animal to graze the land. This is for winter season. Okay. If the Julian day is less than 85 days, that means before March. Again, this is for the northern hemisphere actually. You have to do it differently for the southern hemisphere. Okay? So if the Julian day is below 85, that is below March, okay, and the biomass is above 3,000, again you can allow that. So the key word here is above 3,000. If it is below 3,000, don't do this. Okay? Don't allow the animals to eat the grass. Okay? Because during this winter time period, the crop is not going to grow, right? The vegetation is not going to grow because the temperature is cooler. So that means you don't want to get too many animals in the land that's going to eat all the grass, thereby the summer it will not grow at all. When it warms up, you won't have any more grass. Okay? So that's the reason behind why in the winter season, how to control the grazing operation. So you need to have a good biomass before you let the animal go in. Then there is also stocking rate, that how many animals can eat. You don't want to put hundreds of cows in the same place actually. Okay? So there are management operations that you can control. You can put number of animals as one of the conditions, for example, here. Okay?
When grazing happens, the soil compaction is also effective on soil? Yeah.
In the model, there is a compaction factor, there is a seeding thing like what is called trampling. Yeah. Okay? So one is the compaction of the soil, another is trampling. As the animal walks through this land, it can also trample the seeds, so the new seeds will not come out actually. or the new grass will not come out because the animal is standing on that or walking on that all the time and things like that actually. So you got to be.
It's funny, but there is no module about the poo patches of animal, because nitrogen, they can be source of nitrogen.
Yeah, I mean, we also take the animal manure, put that back into the soil.
So
It's automatically done.
Okay, they have this.
Oh, yeah. I mean, this has been going on for 30 years. We did not think about all this stuff yesterday or day before. We have been working on with this model for 30 years. We thought about all those stuff, what naturally happens, and we try to mimic the best of our understanding, actually. I'm not saying we are doing perfectly in every situation, but we are doing our best. It has got animal compaction, the animal trampling, the animal manure going back to the field, and how much gain, the weight the animal will gain by eating the grass. So there is all type of information goes in here, actually. It's not just strictly a hydrology model, actually. That's why it's vegetation-centric. That vegetation means it includes everything, human, animals, everybody that's involved with that vegetation, actually. Okay? So again, the same thing, rules is implemented here. You can see that if it needs to be greater than 295 days, it should be less than 85 days, and the biomass has to be greater than for both conditions. Then you can graze, allow it to graze. Okay? So this is called winter grazing operation. Or you can have the same thing for summer. You could be different rules, for example. Okay? Hay cutting. What is hay cutting actually? You have 3 alternative conditions, 1 decision. What is hay cutting? This is where you grow grass to feed animals. Okay? You don't allow the animals to eat the grass in the field, but you grow the grass, cut the grass, bale it, and then store it for the winter months or other time period to feed the animals. So how to do that? So here again, in a descriptive form, if the soil moisture is less than field capacity, okay, up to 1.5 times less than field capacity, and the potential heat units of the plant is greater than the maturity, at least 50% of the maturity, because the potential heat units is to full maturity. We need to be at least 50% or more matured before you can start to cut the grass. And the biomass has to be more than 3,000 kilograms per hectare, then allow harvesting hay. So these are the 3 conditions here. The soil moisture should be below the field capacity. In other words, you don't want to be too wet to go and cut the grass. And the plant has to be at least 50% matured. Okay, that's what is greater than mean. And the biomass has to be at least 3,000 or more. Then go out and harvest the crop, harvest the hay. So every time after we harvest it, the next another 0.5, it's going to harvest again. So every 2 months, 3 months, it's going to keep harvesting it actually, as long as it meets this condition automatically. Okay? So in 1 year, it could be 3 months between harvest. In another year, it could be 4 months, depending on weather, depending on the growth, depending on how well the plant is maintained actually, based on various other operations. Does that make sense? Okay? So you will be able to develop your own decision tools and you will be able to import. If you want to know how this is going to look at, you can export it now and take a look at what the format is. And then you can modify your own information and import it back. Okay? We have not given you the editing option yet actually. We will give you editing option soon, where you will be able to type in this descriptive area actually. Once you input that, it will automatically convert to your tabular format. But for now, you can import and export. Okay? If there are specific other questions on the management, please let me know. You may want to go through this. There is a lot of options here actually, a lot of examples we have already provided to you. Like for example, this is the irrigation, right? There are 1, 2, 3, 4 different types of irrigation management. Okay, this is irrigation at soil moisture of 75%. Okay, This is irrigation with the soil moisture, unlimited supply. Okay, so depending on where the supply is coming from. So this is irrigation with stress factor of 0.8. Okay, so this is the irrigation with stress factor of 0.8 again actually. This is unlimited versus this is limited. So if you want to look at that, you can quickly look at this. So what you're saying is if the water stress is less than 0.8, then irrigate, drip irrigation. Okay. So that's what this, there's one condition, one action. So this will automatically irrigate every time the water stress is below 0.8. So when the soil moisture is, let's say this is 100%, as soon as it goes to 0.8, it's going to apply the water. So that could be once in 10 days, once in 15 days, depending on rainfall and depending on the plant growth, depending on the root growth, okay, how much water is needed. Plant needs different water, different time of the season, different time of the growth period. Questions? Okay. So let me try to show you, because there was an interest on the land use scenario. Okay.
So could you show a pesticide application too? Because I think there are some people working with pesticide.
Yeah, okay. In the pesticide, let me see, plant. I don't think I have a pesticide here yet actually.
Okay.
I may be able to show you
fertilizer.
the fertilizer.
Yeah.
So that gives you like 5 different conditions, 2 different actions. You can use this as an example for pesticide also.
Mm-hmm.
So here we are saying if the potential heat units, meaning if the plant is growing, because you don't want to apply fertilizer if the plant is not started yet actually, okay, or about to start. So whereas when you come to the pesticide, normally the pesticides are applied either before planting or after planting actually. So before planting is herbicide like atrazine to kill weeds. After the planting is to protect your fruits or nuts or grains, so it will be well after the growth of your crop. Okay? Then there is a third type of pesticide called nematicide, that is to kill the worms in the soil. Okay? So there are pesticides that's applied either before planting the crop, that's the nematicide and herbicides, and pesticide will be after you plant the crop and the crop is grown and you're trying to protect your fruits or nuts or flowers or whatever that you're trying to do actually. So you can use the heat units to tell when to apply, if it is after planting or before planting. Okay? So that's what this number here. And you need to say which rotation, meaning different pesticides may be applied for different crops. So you may have this year maize, next year could be soybean. So maize pesticide is different than the soybean pesticide. So you have to say what rotation of your crop you want to apply. Do you want to apply on the first year, which is maybe maize? If it is the second year, it could be soybean. Third year, it could be again maize or again soybean, depending on what they grow, farmers grow actually. And then you can also look at, here it is fertilizer, ammonia fertilizer, but it could be the pesticide number. Okay, whatever the pesticide name. Okay, so the next is if the rotation is year 1, if the nitrogen stress, here it is fertilizer because of that it's nitrogen stress, and the plant's growing, then based on the maturity you want to apply the fertilizer. So that's basically what are those 5 different conditions actually. So if you look at the actions, one is yes, another is no. That means if it is alternative 2, don't apply. If it is alternative 1, apply. Okay? So alternative 1 is only for the first 2. The rest is not applicable actually. Dash means not applicable. Okay? So that means if it meets these 2 conditions, you apply the fertilizer. Okay? Otherwise, no. So the second type of fertilizer would be if it meets these 3 conditions, apply, otherwise do not apply. Does it make sense? I know it gets a little complex, but as you start getting used to it and as you start developing by talking to your farmers or getting local experts. But sometimes the farmers may not be able to do that, but the local extension agent or the government, I don't know, it's called extension agent or government officers, agricultural officers, they may be able to provide you some general guidance. What do the farmers do here actually? And how do they apply fertilizer? When do they apply pesticide? Things like that actually.
Eu queria tirar uma dúvida, se é nessa tabela de decisão ou se é no management que eu digo quando e o que. Aqui eu consigo selecionar quais as substâncias, por exemplo, os herbicidas neste período, e aí eu coloco o glifosato, as substâncias. É aqui, né?
Sim, sim, é nessa. É que nem nesse exemplo, ele está falando o que baseado em algumas regras de manejo. Você poderia falar o quando, tipo, se for uma data específica também, naquela outra opção mais certa de data. E aí você diz aqui, nesse caso ali era uma aplicação, mas você tem várias opções ali que você pode escolher sobre o que aplicar também. Tá? Então você pode colocar ali.
Aí eu referencio com o nome que está na base de pesticidas.
Exatamente, você tem que pegar certinho o nome na base de dados. Tá.
Obrigada.
Imagina.
Any other questions, comments? Okay, let me go to the scenario land use example here. And so here we have different things, like for example, we can have a land use based on channel or by just landscape. Okay, whether you're changing this land use along the riparian corridors, like for example, channel like a floodplain or upland. Okay, what is changed here actually? Okay, so in this example, let me open this. There are 7 conditions, so there is lots of conditions here, and then 4 different actions can take place. So this is one of the complex one actually. So, okay, this is channel. Let me go back to the other one first, land use based, then I'll come back to the channel. So here there are 8 conditions and 5 different actions. Okay, I know this is very cryptic. Let's go here. So here are the 8 conditions. So it's all starts with if this is satisfied, then do that something else. So if the calendar year, so this is the year, is greater than 1870, and it is less than 1900. So we are talking about changing land use for a 30-year period actually. Okay? And the probability is less than 0.02 or probability is greater than 0.5. So that's another 2 conditions actually. And the land use management is X, whatever that land use. It could be pasture, it could be forested, it could be whatever it may be actually. You specify the land use information. The probability, yeah, we'll all come back to that actually, yeah. And change the land use to con with no management. Because in 1900, there is very little management actually. Okay, no practice. Okay, so that's one condition actually. So, or if it is same, 1870, 1900, same probability, the land use this, you change it to votes. Okay, and the same thing, same year, same probability is less than 0.02, then if the land use is 2, now I want that to be pasture. Okay. So this land use that you see that's equal to this or O2 or O3, they are the existing land use at that time in 1870. So now we are saying I want to change that land use from there to a corn, to oats, to pasture, whatever that you want to change with certain practices like no practice or fertilizer practice or conservation practice or conventional practice or tillage practices, whatever how the land was managed at that time actually. Okay? The probability is how much land. Do you want to put 20% or 50%? Okay? What is the distribution? Okay? You don't want to convert all of them. Okay? So you could do gradual from 20% to 50% over the 30-year period, actually. Okay? So you're not changing your land use all on 1 year, actually. Okay? We are going to change it gradually over the 30-year period. The land use will go from 20% of the land use to 50% of that land use will be converted to corn, no practice, or oats, no practice, or pasture, there's no practice. Does it make sense? So that's what that condition is all about. So same thing goes on for more land uses, actually.
Nesse sentido, eu estou pensando, por exemplo, a gente tem os dados de change use do Map Biomas para algumas bacias. Eu posso pegar aquela série histórica deles e ir alterando aqui para ver a mudança. Mas aí eu vejo a mudança no ciclo hidrológico, ou eu vejo qualidade. Eu não estou conseguindo entender direito qual que é a mudança que eu vou ver quando eu mexo na tabela.
Tá. Então, na verdade, você está mudando, você vai partir de um uso do solo, de uma data que você vai escolher, que pode ser, por exemplo, a mais próxima ou a mais antiga, não sei, uma data fixa que você tem de uso do solo, um mapa bom de uso do solo, certo? E aí você vai definir todos os seus HRUs com base nesse mapa, certo? E aí, depois, o que você está fazendo aqui é que você está alterando o seu uso do solo ao longo do tempo. Então, principalmente se eu estiver usando aí desde a década de 60, por exemplo, no Brasil, teve um aumento significativo de urbanização, a gente teve mudanças na agricultura na sequência, diminuição, enfim, tanto faz, depende da sua região, certo? Então, aí você pode colocar isso nessa tabela. Então, você tem mapas do Map Biomas também, por exemplo, para vários anos, uma série histórica. Então, você pode converter isso em algo que pode ser inserido aqui. Tá? E aí, como que isso vai alterar? Isso vai alterar todo o seu modelo. Então, tanto a parte hidrológica, como a parte de qualidade, de produção de sedimentos, tudo. Tá? Porque é diferente. Você tem uma floresta e você tem uma área urbana, o que está alterando? Está mudando só o ciclo hidrológico, mas está mudando também a sua questão de produção de sedimentos e qualidade, por aí vai, né? Então, vai alterar todo o modelo em relação a isso.
Aí eu faço simulações separadas. Ou ele já vai rodar junto?
Junto. Nesse caso, tá. Ele está pegando para uma série... Então, eu vou falar duas possibilidades. Aqui, eu estou pegando uma série histórica. Então, eu quero replicar o que aconteceu no passado e conseguir calibrá-lo bem, né? Por exemplo. E aí, eu preciso replicar, se for de interesse, o que aconteceu nos últimos 30, 40 anos. Eu quero entender isso, então eu tenho que inserir a mudança de uso do solo gradual nesse período. Tá? Então, eu insiro aqui, ele já altera dentro do modelo, e aí você tem uma resposta que já está levando em consideração a mudança no uso do solo. Tá? Agora,
não
se você
igual
tem...
antes, no SWAT anterior, que eu alterava, rodava o modelo. Aí alterava de novo e rodava. Eu só vou precisar rodar uma vez.
Sim, nesse caso, sim, se você quiser fazer gradual. O que você pode fazer, por exemplo, são cenários futuros, que aí é a segunda possibilidade. Eu quero ver como, ou quero testar diferentes mudanças de cenários na minha bacia. Então, o que aconteceria com a hidrologia ou com a qualidade de água se a área, sei lá, floresta fosse alterada e reduzisse para a agricultura? O que aconteceria? E aí você pode mudar isso. Aí você pode fazer um cenário separado, ou você pode fazer aqui também, como se fosse uma tentativa aqui. Aí você teria dois modelos diferentes, entendeu? Você faz um que seria o atual, que aconteceu mesmo, calibrado bonitinho, validado, e aí você testa cenários nele, tá?
Tá.
Tá?
Obrigada.
So, if you look at the tabular data, here you can see that these are the 8 different conditions, like the year, calendar year, again, this should be greater than, this should be less than, and this should be less than, and this should be greater than. So these different conditions, actually, if all these things are all met, then change it to con. Everything else is no. You can see that there is only one S for each conditions or each thing. So this is all the conditions actually. You have to meet all these conditions in order to turn on one action. So in every row, you will see there is only one action. Sometimes there are two actions, but then again, within this column, there is only one action always actually. Okay? So that's how you can have multiple triggers at different time. Okay? So this becomes a little complex. If you want to implement this type of changes, it becomes complex. You need to think about all the different things that can happen in your land use and then implement the change accordingly actually. Okay? Any questions so far? Yeah, the probability is the percentage of change actually. What percentage you want to change? Okay, do you want to change 2% or 5%? What you want to change actually? How much you want to change? We are not changing all of it actually, only a small fraction of that changing from one HRU, because you are not going to change all forest to an agriculture. There will be a slow depletion of forest and converted into agriculture. So that's what that is.
For example, let me just...
Sure.
So here, for example, if you go through, it's changing from 1870 to
1900.
100, and it's changing from 2% to 50%
over the 30-year
period. So it's changing gradually. What was the land use? I don't remember.
It's changing it to corn.
Corn
no practice.
from
Corn no practice. Yeah.
But before it was.
It was. I think
forest?
it was forest.
Okay.
I think
So you had forest.
No, here is the land use. That land use one. Whatever the land use one is actually.
So it was some kind of land use, and then in this 30-year period, for example, if it was forest, something Brazil, and then in this 30-year period, it's changing from 2% to 50% to corn. Okay, gradually. So it's changing.
So the land use one. Let's say the land use one was forest.
Mm-hmm.
Okay, this is a generic table just to give an example only actually. So in your watershed, it could be specifically a forest. You can say forest, deciduous forest, whatever forest may be. Then if the forest is equal, that means we are saying if this is equal to forest and I want to change between 80 and 1870 to 1900, 2% to 50%. So we take that land and slowly, gradually, okay, it's just a linear scale, okay? So what is, there is a 48%, right? 48 divided by 30, whatever that much percentage, it will change over that period.
I'm just confused because those informations are in the condition part. Like
yes.
If probability is less than, but where is this information? Like how does the model know the probability? That's what.
Okay.
That's what.
Yeah, I see your confusion actually. The probability is, in a way, here is the percentage of change is what they're representing a probability. It's not the right word. Probability is not the right terminology to use here actually. We may have to change that to something a little bit more descriptive or more cleaner actually. Yeah, we will look into that more closely and what's the best way to do that. Let me look at another example and see how they've done that. There is one more example on 1930. Okay, what does this looks like? Here also they are using the probability again actually. Okay, so let me find out if there's a better way to do this, and we can try to modify that actually. Okay. Any other questions on the decision tables in general? Right now, the decision tables are implemented only in these 4 categories: one for flow, and one for land use change, and reservoir management and land use management. And we will be adding more of this in the future, actually. As we think more and more how the decisions are made, how things are changing, then we will be adding more of this, actually. But these are the 4 that we can immediately see that has got human impact, actually, especially the land use change and ag management and things of that nature. Reservoir management is another operation that human controls most of those decisions, actually. So that's why we kept only those things as an option. But if user comes back and say, hey, I want to control this or I want to do this differently, and then we can keep adding more management tables here that can trigger different parts of the model at different time of the year and things like that, actually. So that's basically, the rest are all basic databases like tillage database, fertilizer database, and things like that, actually. They are not that, they are very same as what you saw before in SWAT also. Like here is all the plant database. Okay, every plant that you can think of is here, actually, more than 254 different plant types. Or fertilizer type, for example. So there is about 58 different fertilizer type, including the animal manure. So if you go down here, you will see all the animal manure, like dairy, ducks, goats, horse. So we can see each manure, how much is the concentration of nutrients and things like that. And tillage practices, pesticide database. So this is the pesticide database. So this gives you the environmental fate and transport of pesticide, actually. So if you apply 2 kilograms of pesticide, what is the half-life? How long it's going to be in the leaves? How long it's going to be in the soil? How it's going to infiltrate? How it's going to dissolve? How it's going to attach to soil particles? Okay, absorption coefficients. So these are all the chemical transport coefficients that we used in the model. Okay, and then the urban database, septic systems, and then finally the snow parameters, generic snow parameters. Okay. Then there is some structural BMPs, things like tile drain systems. We talked about tile drains. Okay, so if you want to add a new tile drain, you just create a new record. Okay, so once you created the new record, when you go to your land use management, you should be able to see that, actually. Okay, that new record will be shown here, and you can also look at that in the land use management. Okay, when you click here, you can go here and select the tile drain. Right now it shows only 1. That's because in the database there's only 1. Okay, you are asking me the question, right? So this is how you can create your own management, and then you'll be able to point that to different HRUs. Okay, there are septic system, filter strips, grass waterways. Okay, and you can define your own BMP also, actually. User-defined BMP, like engineered solution, for example. If you don't know how it's managed, it's difficult to model, you can just say, okay, I know this BMP will reduce by 30%. So assume there is going to be 30% reduction. So it will automatically remove 30% and route the rest, actually. So that's what we call engineering solution, actually. You don't have to know how it's done, it's get done, actually. Now you go and figure it out, how to get it done. Yes?
Professor, I have a doubt.
Yes.
Can I insert in BMP payment for ecosystem services, something like that?
I mean, it is not the agricultural payment, actually, because it's not economic, but what you can do is you can take the output from the BMP before and after.
Oh, okay.
And then get the per pound
Gotcha.
benefits. Then if you know the dollar amount, or if you know something about, okay, every kilogram reduction in nitrogen, this is how much is equal to in terms of dollar. So then yes, you can do that, actually. Yeah.
Thank you.
Mm-hmm. Any other questions before I move to the next step, which is running the model? So once you have done all this stuff, all the editing and all the things, I have not done anything here, just explain to you what are the features available here. And once you're done all this stuff, now you can go write input files. Okay? It's going to write into this folder. Everything is in the database, right? all the editing that you have done in the previous step, editing SWAT inputs, it's editing your project database, like the demo1.sqlite in my case. Okay? So now, when you go here, in the same demo one, there is a folder called scenarios, default, text in out, just like the old system. Okay? So in this place, it's going to write all your inputs. So I'm going to say save and write files. Okay? If there is any existing file, it'll get removed and it's going to overwrite it actually. It's just asking you, is that what you want to do? You say yeah. So it's not now starting to write them. If you want to back up, you can just go there and back it up. Actually, future we will have opportunity to back it up and things like that. Okay, so the input files are returned successfully for the text in out in the text in out folder. Now it's time to run the model. Okay, so you come here. The next menu is run model. You click here, and you have two options. One to run the non-debug version, which will be faster, okay, or debug version, which will be slower. Okay, so I would always recommend to run the non-debug version first. If you run into problem like there is a crash or something wrong, then you come back and check this box and run. So it will give you meaningful message saying that it crashed on subroutine and for line number X, so that you can go back and debug that quickly for you. It may also give you input line and things like that. Okay, so I'm going to uncheck this for now and say run. So now you can see the model is running. We will remove all this stuff in the future, but right now it's showing you model is running. Okay, so we are running the model from 1990 to 2013, right? So that's how many years it's going to run now. But it's related. You can see it's immediately started running because there's only 30 files. Unlike previously, we used to have 300 files to run for a watershed like this size, actually. Okay, it's crashed. Okay, so it's time to do the debug and see. Yeah. How many others are able to run? It's okay. It's running. Good. Any questions while it's running, actually? Any other questions or any comments? Okay, it's successfully done. It's still running for all of you? I can wait, no problem. So, what is it?
Take here, it's better to show you the error. The
error message?
Yes.
Okay.
It's better to show you.
Okay.
Traz aqui também.
Yeah.
Mostra ali, ó. Pra gente ver se, acho que deve ser o mesmo erro.
Output file.
It stopped in 92.
Yeah. LSC output, command, time control, okay. So something is, okay, this is after 3 years, okay, subscript number 1 array, less than the lower bound, okay. So something's getting divided by 0,
Yes.
that's why it's giving that. Did you modify any other input file
No.
in anywhere? Okay. One thing we
Not that I
could,
remember.
okay, the one thing we could do is, we can go back, cancel this,
Yes.
yeah. And let's go back to the top one actually. And edit file database setting, open up, let's import the data one more time.
Here?
Yeah. And browse
I need to
to,
find
yeah,
my
yeah, your
projects.
project file, yeah. Yeah,
It's a lot of.
yeah.
Yes.
Oh, this is a copy is what
Yeah,
you're
copy,
working?
copy, yes.
I see, okay, that's course, yeah,
Course.
yeah.
Yes.
Please, and open.
Wait. Import new.
Yeah. Start import, yeah. So once it's done, you can directly go to write the inputs and run.
Because I
Just
can't
see-
have what file
Yeah,
setting.
yeah.
Yes. Não, porque eu posso ter modificado alguma coisa sem querer naquelas. nas entradas.
Yeah, so I think we can just rewrite the input one more time just to make sure it's not. Let's go ahead and open the project. Just to make sure we didn't accidentally did something. Where is the project located? Oh, this one. Demo. Okay. We'll just do a new import actually. No, continue. Start importing.
I have to save and write again?
Hmm?
Or go direct to.
No, no, you have to save and write again actually. Yeah. Because you re-imported, you have to do that.
A gente vai ver se você fez alguma mudança ali, de repente, por isso que está dando algum erro.
Okay. So we can directly go to the right input files now. The only thing I didn't is
Starting 92 again.
same thing.
But it's, no, but now he said the access violation. Something, maybe one
No,
of
no,
the
no, same
folders.
machine. No, no,
Same?
same problem. So there is some basically problem with our GIS operations, and let's see. No, it should not take this long. Okay. Same. Yep. Something, yeah, something in the watershed delineation process, it got corrupted. So we need to take that and take a look at what's wrong with this project actually. If you can zip the, one of you can zip the project and send it to me, I will take a look at, we can, yeah, yeah, thank you. Oops.
No, sem problemas. I knew this was going to happen. No worries.
Okay. I know a few of you could not able to run the model actually, so you may have to watch your next computer for time being. You are able to successful? Run? Okay. So now that we finished, oh, everybody's good. So now we have run the model successfully. The next step would be to import the data, right? That's the last menu here. To analyze the output, first you have to import, because SWAT reads and writes to a text file. Okay, all the outputs are in text file. So we have to read the text file back into the database, output database. so that we can go back and visualize in QGIS. Okay? So we are going to say import. So this is the last menu here. Actually, if you click on the last menu, after successfully running the model, you should be able to import. If there is any existing output file, it will overwrite actually. So if you want to back up, you just back it up in another folder and say, right. So now it's reading all the output files from the model run, and it is storing into an SQLite database, model output SQLite database. It can take a little time depending on, because this is almost 20 years, 23 years of data that we are running. But the number of subbasins is less, HRUs are less, so it should not be too difficult, too bad. Any questions while that's importing the databases? Any questions? Yeah, there are time. Okay.
They are wondering where they can put the various land use maps infos into the SWAT Plus.
No, like I said, you don't have to put the various land uses, you put the decision tables.
Okay.
So you start, let's say you are starting your simulation from 1950. So you put the land use map for 1950. Then every 5 years, 10 years, depending on what land use map you have to estimate the change, the land use change for those time period, and then make that as a decision table. In the decision table, you can say 1950 to 60, these are the conditions. This is how the land use X changed to land use Y. Okay? So it is not in SWAT Plus, you cannot directly give multiple land use file and automatically it figure out when to change actually. So you have to do that external GIS analysis and take those data and then bring it to SWAT Plus editor and develop decision tables to represent the change.
No? Entendi.
Thank you.
Yeah, it's a little slow importing because it's reading all the ASCII files and we also asked for all the output files, so we could have reduced to only the limited output files.
So Srini, can I ask on the BMPs,
Yes.
for especially like for urban areas, if you have like big reservoirs for flood control that we have in many cities here, or if you want to run scenarios with more sustainable practices as
Yep.
well,
Yep.
you could add that all in the BMP part?
That's right. That's right. So in the management, I know I've shown you a lot of agricultural management, but we also have urban management. In the urban management, we have two kinds of urban management. One is what I call soft BMPs and hard BMPs. Hard means structural, like ponds. So you can have a detention pond, retention pond, irrigation pond, wet pond, and sedimentation pond. Okay? So you can have 5 different types of pond. We call it as pond. It's not a reservoir like a big pond. Okay? And then on the soft BMPs, you can do things like roof garden, rain garden, okay, or porous pavement, okay, and then cistern. So those are the 4 soft BMPs that you can implement to reduce your runoff and reduce the energy. Because if you have in Chicago, all the government buildings now have a roof garden. So that reduce the temperature, the cooling temperature or the air conditioning by almost 30% actually. Because they are able to put vegetation on top of their top of the roof actually. Then in a lot of other places, they want to take the rain water from the roof and store it in a barrel, then automatic irrigation for the plants around the houses. Okay? So that's another way of reducing urban pollution actually. And the third is porous pavement. So right now they have made a concrete that is as strong as a concrete, but it can percolate water to the ground. Okay? It is not going to run off. As it soaks, it goes into the ground, especially parking lot. So where you park your car or any places, public institution, they want to make that as a porous pavement so that it can absorb the water and stay there rather than running off to the nearest river and things like that. So those type of BMPs you can simulate now in SWAT and the SWAT Plus actually. And then the other nice idea about here is you can also run it at a sub-daily time step to capture some of this process, especially the flooding process and things like that. Yeah.
Very good.
Okay, it's imported. How many of you are still running? Is it still importing? It's finished? How about others? Everybody's finished?
I'm still
Okay.
importing.
That's good. So you have faster computer than mine then actually. So what about online? Everybody's everything on board? Okay. So now we are going to exit the SWAT editor so that we can go back to the visualization, to the QGIS and start visualizing the output. So I'm going to say exit now. So as soon as I exit it, I have the visualization activated now. So it automatically knows that we have successfully run the model and we have saved the simulation. Okay? It's still importing?
No, she said it didn't show the step 4 on hers. But you imported it? Yes.
It's finished, successfully
Finished.
completed?
But it's not showing the 4?
Can you,
Close and open.
can you cancel and open again just to make sure? So I can cancel and I can, if I open it again,
Yeah? Oh, great.
it's here. Okay.
So it was open.
So sometimes there's a
Yeah.
refreshing or slight delay.
Yeah.
Okay. So now we are ready to do the visualization part. I'm going to click visualize. Okay, I clicked visualize and that opened this interface here. So I'm going to move my screen slightly so you can see what's happening. I know I put this channel number. I'm going to put back to the subbasin number so that we all can be on the same page. Okay, I'm going to take that off the channel. Oh, I want a channel, but not the number. I'll just call it as no labels. Okay? So this is our watershed that we are modeling, except this region. We are not modeling this region. And now, let's say we want to, if you have multiple scenarios, you will see the multiple scenarios here actually. Right now we ran only one time the model. Let's say you come back and run a BMP scenario, land use change scenario, okay? Management scenario, whatever, climate change scenario. Whatever scenario you run, then you will see multiple options to choose from, multiple outputs to choose from. Then you have to choose what output you want to analyze. Okay? Anything that's with the end MON means it's monthly output. YR means annual output. Okay? So you can choose whether, because we ask for monthly and annual only. If you ask for daily, you will get a daily output. DLY, output will be called DLY. This is aquifer, as the name suggests. This is channel. So when you move your cursor, it tells you what are the information it's going to have. It's a monthly channel water balance, incoming and outgoing sediment and nutrients. Okay? Channel morphology, okay? And sediment budget. This is for monthly losses. Losses meaning nutrient loss, nitrogen loss, phosphorus losses, and things like that. Like what's associated with runoff, sediment, and so on. Okay? This is the nutrient balance. How much you applied, how much is converted, how much stays back in the soil, all those stuff. And the next one is plant water, plant and weather. So this gives you the plant growth, okay, the biomass, crop yield, heat units, all those stuff actually. So this is water balance by HRU. All the water balance, rainfall, runoff, recharge, shallow aquifer, return flow, all those stuff by HRU by HRU. This is by landscape. LS means landscape. Okay, nutrient loss by landscape. By the way, this is the spatial objects, aquifer, channel, HRU, landscape. LS unit means landscape unit. Yeah, that's all. So those are the 4 spatial units, and the underscore LS means losses, nutrient balance, plant water, water balance. So those are the different outputs. So let's start with the water balance first, actually. Then we can go to the other interesting stuff. So let's say you want to look at the channel by month. So I'm going to choose channel, what's happening in the river. You can take any period, actually. Remember, we ran the model from 1990, but we did not print first 2 years is a warm-up period. So we don't have any output for year 1 and year 2. So only from year 3, which is 1992 to 2013 is what we have the data for. But you can choose to analyze any subset. Okay? You can say, I want to analyze from 92 to 95, or 95 to 2000. Whatever time period you want to analyze, you can analyze the data. You don't have to analyze all the data. Okay? Or you can even compare 10 years this and 10 years here. What is the difference? What is the difference in hydrology, for example? What has changed? So, or you could be running a land use change scenario from 90 to 2000 was one land use, 2000 and beyond is another land use. So you can compare the 90 to 2000 and 2000 to 2010, different land use. So depending on your analysis, depending on what you want to do, you can choose your time period of analysis. Then, I think, yeah, it's a little bit, I think my screen or the resolution is not great. I may have to change my font size slightly. But anyhow, this is the place where it's going to save your shapefile with all the attributes. Oh, maximize and minimize. You know, that didn't help. That's okay. So here are the variables. Okay. So in this output file, channel SD monthly, these are the variables actually. So here again, precipitation, evaporation, seepage, flow, sediment, organic nitrogen, sediment phosphorus, nitrate, chlorophyll, ammonia. So these are all the constituents or water quality. And the other side is storage. What is stored in the channel, what is coming in, all the ins, and then all the out, what is leaving the channel. Because this is a channel output. That means for every channel, what's coming in and what's leaving the channel. Okay? And what is stored in the channel. So storage is what is in the channel right now, or month or day or year, and what's coming in and how much is leaving from that. So typically we want to look at what's leaving the channel, right? So let's say flow out. So go here and select flow out. Okay? Oops, Python error, why? That's okay. Okay, flow out. Then you have to choose how do you want to summarize your data. Do you want to sum of all the months, or do you want to get the mean monthly value, or mean annual value, or you want the maximum, or you want the minimum? So depending on, because this is the time series data, for every channel we have data for 1992 to 2013. That's almost 22 years, right? So 22 times 12, that's how much data you have actually, because every year 12 months, monthly output. So do you want to sum all those values? That's total. Or do you want to get a daily mean? Daily mean doesn't make sense because this is only monthly output. Daily mean is only for daily output. So monthly mean, so you take every 22 times 12, that many months, you divide it by that and then give you the mean monthly. Or mean annual. Or over these 22 months, which month got the highest flow and which month got the lowest flow. How much is the lowest, how much is the highest. Because that gives you the range. So you can choose any statistics. So let's say I want to do annual mean. Just take an example, annual mean. Then you say add. So we have added flow. You can add other things, like let's say I also want to look at sediment. Same annual mean, add. You can add any other variable you want from here actually. Okay. Let's say organic nitrogen, add. So you can add as many variables as you are interested to create maps for. So flow, sediment, organic nitrogen are the three things I just added actually. So once you've done that, now you select which variable you want to plot, map, and simply select create. So when you click create, it's going to show you the flow, mean annual flow in the river for the 22-year period. Okay, so here is the mean annual flow. So this is the mean annual flow here. So as you go towards the watershed outlet, it's larger, which is what we expect, right? So this gives you where the water is coming from actually, how much water is coming from each channel. Any questions in understanding how to plot maps? Yes.
In my case, sometimes always in the output table, I would get the flow in would be bigger than the flow out, and then I checked online and it's like normal to get that.
Is it if the flow in is bigger than flow out? There could be only two reasons actually. Either there may be some point source that may be removing water. That's one possibility, or you have a lot of seepage loss. Depending on what you put in the seepage in the channel, so there may be a lot of things going to aquifer. Okay, and of course there is also evaporation. Okay, so it's possible that flow out will be less than flow in because of these three reasons: evaporation, seepage, or point source. One of the three.
And flow in doesn't mean that it's flow in like at the upstream. It's like flow in from all over the HRU.
That's right.
Okay.
So flow in is basically all the contribution coming from upstream plus all the local contribution. Okay? But here the local contribution is by channel, not like subbasin. Previously it used to be all the subbasin, all the HRUs. Now in SWAT Plus, it's only the HRUs that is contributing in that channel. Now your output is by channel, not by subbasin actually. So it's much more detailed. Yeah. Yes.
And can we see mass balance for each HRU?
Yes, there is a specific output called water balance output actually. Annual water balance or annual average water balance output. That's a text file.
Oh, okay.
That's not a map or
No,
anything
but-
like that.
but
Yeah,
yes.
you can open that and then able to see that. Yes. And if you want a sediment output, you just simply select sediment and say create. So that's your sediment. The sediment output is a lot different than the flow output, as you can see. Okay? So one of the reasons could be there may be a lot of deposition is happening. Okay? And most looks like this particular subbasin producing a lot of sediment. But when you look at the sediment, it's just one part of the equation. This is just showing you what's happening in the channel. We also need to look into what's happening in the landscape. Okay? So I'll show that a little bit later on HRU output or sub. We'll be able to see that by landscape unit output. If you are interested in organic nitrogen, you click organic, then you get the organic nitrogen output. So it's a quick way of analyzing your model output, okay, depending on whatever way to analyze your data. Like this, you can choose any output file, any output variable, any way you want to analyze your data, and then plot it. If you want multiple plots, you can also do what we do is we do a copy. Okay? If you want to save the organic nitrogen, I simply copy the layer and paste it. Not rename, paste. Where is paste? Maybe here. Yeah, paste the layer. So now I have 2 organic nitrogen, right? So I can come back here, and this time I want this to be, let's say, sediment. So now I have a sediment and organic nitrogen. So I can turn on and off to see the difference between the two. Right? You can turn on and off. If I'm going too fast, let me know. If you want me to repeat anything, let me know. Okay? So now let's say you created the 2 maps. You can have 3 maps, 4 maps, however many maps you want. Now you want to print this on a side-by-side map, actually. Okay, so that you can see both of them in the same screen. So you can say landscape or portrait, how many maps you want. Let's say I want 2 maps here, and I say print. So it prints on side-by-side here, actually. And you can export this into a PDF, you can send it to a printer, or you can save it as whatever you want, actually, and you can change name, and you can change the title, all these different things you can modify now. So you can create a high-quality map that you can use for your publications and things like that, actually, right here. Do you want me to show this again? How we did it? Yeah. Which one? How to make it 2? Okay. Let me go through one more time. So you take the layer, whatever that you want, right-click, copy, okay, and click on the results, right-click, paste. So when I paste, it's going to copy that again, actually. So now I have sediment, organic nitrogen, and say again sediment. So this time I can now ask to plot flow. So I selected the sediment and I'm say create flow. So now that changed to flow. So I have a flow, organic nitrogen, and sediment, all 3 maps now. Now I could say, oops, sorry. Now I can say create 3 maps. Okay? You can create up to, I think, 6 maps, I believe. Yeah, up to 6 maps you can create in one sheet. So let's say 3 maps, maybe portrait, one after another, print, so you'll have the 3 maps. Does that make sense? Any questions? I think this afternoon you're all going to have a free time, so I want you to practice a lot of this stuff because I'm just showing you one output file and one, so you want to play with this and maybe make it, so that you can come back with more questions tomorrow morning when we discuss, so we can show more actually. I'm not doing enough time because I know we are going to stop in another 10 minutes. I'm not able the time to go through everything now. We will continue this tomorrow morning also actually. That's a plan, right? Okay. We'll continue tomorrow morning, but I just wanted to show you this so that at least you can practice a little bit more. So let me also show you the next, if there is no more questions on the how to make maps. I could make maps for HRU, I could make for map for landscape unit, aquifer, everything we can create here actually, okay? So in the interest of the time today, I'm going to move to the next option, which is animation. Okay? So you can create movie with this actually. You can direct movie now. Okay? So you are going to create a new movie now, a new animation. Again, you can choose what file that you want to use. Select the variable. Let's say you want to look at, again, I'm going to go with sediment or flow, whichever you want. Let's say sediment here. So I selected the sediment, and you can animation mode. When you want to print or when you want to save, you want to be in the print mode. When you want to visualize on the screen, you want to be in the map mode. Okay? And the speed is right now 1 frame per second. You can speed increase it, decrease it, and you say animate now. Start the button. So now you are seeing the animation of your flow on a month to month. You can see the month on the top here, and here is the flow information. So here is a label, and it's showing you how the flow changes. Oh, sorry, this is sediment. Okay, yeah, this is sediment, not flow. Okay? And if you want to save this animation, you can simply select here, and it will print to a file. And it will combine all those images into one file, actually. It's like a GIF image. Okay? If you want to increase the speed, you can make it speeder, go faster, actually. So you can increase the speed. Now it's going a little bit faster. So if you made a recording already, you can also play outside. Just you can say play, then it will play outside. So there are lots of options here actually. Okay? Again, you can take any output file, HRE output file, landscape output file, river output file, anything you can do, any variable you want, you can do this. Okay, the thickness is the width of the river. So as the river gets bigger and bigger, your thickness also increases, yes. And this is something you can control also. In the interface, you can say, okay, don't make it too thick, actually make it thinner. You can do that. It's just a multiplier to your, so that we can see that clearly. Questions on animation? Again, please do practice more with other output files. Get a feel for this. We can discuss more questions tomorrow morning. Then I also want to show one more before we close, is the plotting option actually. So this, so far we looked at the spatial map, okay, or spatial map with time series animation. So now we are going to look at one location the time series, like graph, like stream flow on location X, wherever you want to locate it actually. So if you have observation data set like your stream flow measurement data or sediment measurement data, you can also load that. Okay? So again, I'm keeping the same channel, and you need to select the variable again. So let's say I want to look at, let's take flow again, flow. So you have to select where do you want to locate your flow actually, which location you want to plot the flow in this, along the stream. Okay? So you need to know where you want to plot that actually. So there are 80 units here actually that you have to choose that. So we need to know what is, if you want to look at the outlet, we need to know that actually. I don't think you can just simply choose that. So to do that, I may have to turn on my channel reach code. Yeah, so here is the reach code. So that is up to 80 different channels here, right? So I need to know what is my, let's say I want to look at the outlet, that's 51. Okay. Okay, again, if you're not sure how I got this, click this channel, double click this channel, go to the labels, select single labels, and in the label width, select channel. And then click apply and OK. So that will show you the channel numbers. So right now 51 is the watershed outlet. So if you want output at that location, I have to choose 51. And I click add. So now I am plotting at the outlet for flow. So if I want sediment, I select sediment. Okay. Same at location 51, add another plot. So, oh, sorry, this is flow. I don't know why that changes. That's flow, this is sediment. Okay. So you can keep on adding as many different variables as you want for each of them. So once you have done that, now you can say plot. It asks you to save. So I'm going to call it as test. It's saving in your project folder only. Okay. Save. So that's your stream flow. And here is your sediment. Sediment is very, very low, or it's a different scale. So I think you can put that in a different graph. I need to find out how to do that. Yeah, I need to find out how you can change two axes. It's possible. So this is the time series from 1992 to 2013 stream flow at the watershed outlet. If you selected multiple locations, you can plot at multiple locations. Okay. You can change from line graph to bar chart if you want actually, and I say update, so that becomes bar chart. Okay. You can also plot, if you have your own file like observation in the format, you can plot that file directly from here. Any questions on how to do the plotting? Do you want me to show you again, or anybody? I might have gone too fast. Anybody needing me to show this again, the plots function? Okay. So this is going to be your exercise for this afternoon, to play with the output tool in mapping, animation, graphing, and with all the different output files, different things that you're interested in, then we'll come back and discuss that tomorrow morning more in detail, actually. Okay?
And
Bring more questions.
yeah. Also, if you have already like a research question that you are working on, then you can try to find out how you would use it and try to apply something that you are going to use in your project, and then we can discuss that later on too.
Yeah. So from here onwards is more discussions, more questions, more things, and I know Daniele has got some presentations and discussion on data sets, how to get data sets for Brazilian watersheds and things like that. So she will be tackling that on tomorrow, and then after that we have some free time to discuss one-on-one or in a group on any research questions that you may have. And I'm open to any other suggestions that you all want to talk about.
Well,
They asked about calibration too, so
Oh, okay.
maybe we could do just a presentation on calibration.
We can make a
tomorrow.
general presentation on calibration, on SWAT plus CUP is still work in progress. And if you know SWAT CUP, SWAT plus CUP won't be any different. It's exactly identical to SWAT, so you won't have any thing. But we also have a built-in calibration tool in SWAT plus. It's still in the works. It's not completed every aspect. So I would rather wait to show that tool actually. But I can talk about generally
Yeah.
the strategy for calibration and things like
Yeah,
that.
I think we can maybe talk about just how to calibrate and
Yeah,
what to
some manual
take in
calibration,
consideration.
yeah.
Yeah, not necessarily the tool for
Sure.
this right now.
Sure.
Mm.
I can make a presentation on calibration tomorrow on that
Mhm.
actually. Tomorrow afternoon or evening, whenever the data is completed, I can come back and make a
Yeah.
presentation about uncertainty, about calibration and things like that.
They were wanting, yeah, they asked too, so I think it's a good idea. Nice,
okay.
yeah. They are seeing you over there. Watching.
No, I think that's something on my system actually, so I won't worry about that at all actually. I don't think, that did not affect anything what I was doing actually. Yeah, it's saying some update units, access, things like, no, that's not the error. Here is the error. Warning, it's not a error, it's a warning message, some kind of warning message. Yeah, don't worry about it.
Okay. So I think we'll start tomorrow at 8:30 again. So you have the afternoon to play with SWAT plus.